Hello, everyone. Today, I'm going to be chatting a little bit about why I am still finding secrets in your code. Still, yeah. So who here has found an exposed API token or maybe a password in a piece of source code before? Anyone? Yeah. Who's here accidentally committed API tokens? Me for sure. But yeah, pretty much this research is the last 8 months. I've been looking into exposed credentials across different open source ecosystems, primarily package managers, so NPM and PyPy, as Paul was talking about before, and why that's happening and what we can do to fix it. As a bit of an agenda, we're going to run through what exactly secrets are, if some people aren't familiar, and which organizations are accidentally exposing them. The results from my research into the Node and Python package registries, so NPM and PyPy, and what I like to call the perfect storm, pretty cool name, right? But of why this is happening in these different ecosystems and what you can do to fix it. And then we'll run through protecting and attacking, so some of the methodologies and tools that I use and how you can do it yourself if you want to. But first, what are secrets? So by definition, a secret is something that is meant to be kept hidden or unseen by others. In this talk, we're mainly talking about API tokens and exposed credentials, right? So all these services have API tokens that you can use to talk to them, and this is what I've been finding. What I'd like to point out though is that not all secrets are built the same. So primarily when I'm talking about secrets, looking at impact and the impact of those secrets if they're exposed, if they get into the hands of bad guys. Some are meant to be exposed, right? Whether it's like on the client side or the server side. But primarily I'm talking about things like API tokens, database credentials, usernames, passwords, different authentication tokens, JWTs, things like that. And it affects large organizations. So not just small orgs or individuals, but it does affect these guys more. But yeah, some really mature organizations that would have mature security programs, right? It slips through the gaps that these secrets are being exposed in these open source ecosystems, and it has some pretty bad impact for them. And when I was writing this, I was thinking, why are these orgs that have big security programs affected? And it really comes down to the ecosystem that the secrets are exposed in. So primarily in this talk, I'll be talking about NPM and PyPy. And with NPM, it's really hard to map your footprint inside the package registry, just by the way it's built and how easy it is for developers to publish to these ecosystems. It's quite difficult, and this is why I think it affects these large organizations, because they just struggle to map it out. Sweet, so we'll talk about the results from this research first up. So in total, I scanned 4.2 million packages across the Python registry, PyPy, and NPM. At the moment, there's around 3.5 million packages in NPM itself, and about 700,000 in PyPy. Out of this, I found 10,000 verified secrets. So just to preface this, I used TruffleHog. I don't know if anyone's heard of TruffleHog before. Yeah, basically it's just a secret scanning tool. It's written in Go. It's open source, it's free. I think there's a link in this talk about it. But basically I just use that to scan these pieces of code for secrets. And it has some really cool features. So it actually allows you to verify secrets as you go. So I'll make an arbitrary API call out to that service to verify that they're live. And that saves time when you're running through 10,000 secrets or even more if they're not verified, right? And it has over 800 detectors, so it will talk to 800 different services, find secrets for 800 different services like AWS, MongoDB, things like that. So it's a really cool tool to use. So out of these 10,000 secrets, I had around 50 submissions. So when I talk about submissions, that's to self-hosted security programs, vulnerable disclosure programs, so VDPs, bug bounty programs like hosted on BugCrowd, HackerOne, Integrity, things like that. And it made me a nice chunk of change in bounties. So when I went into this research, I wasn't actually expecting to find anything at all, really. The bounties sort of came as a byproduct from it. Honestly, when I started it, I was just looking to get a blog post out of it, but it sort of snowballed into something more than a blog post, and it's consumed the last 8 months of my life. But yeah, you can see, so the priority ratings down here, if you guys aren't familiar, when you submit a bug to like a bug bounty program, you get a priority rating. So P1 is critical, or on Integrity, they also have exceptional, but I've sort of looped them all into P1 there. And that's based off impact. So as a bad guy, what could I do with this key if I wanted to do naughty things with it, right? And P1 is pretty bad things. But P2 is high, so that's high priority. P3 is medium, P4 is low. So actually a lot of P1 bugs here, I wasn't expecting to find this many. They're sort of, the way secret scanning works is that it's quite easy to do. The hard part is working out where you want to look for these secrets, right? And they'll be classified as sort of low-hanging fruits in the bug bounty world because you don't need to be that technical to find them, which is interesting because there was a few P1s here that I found. So out of this research, I've sort of mapped out the services that I've found keys for. And you'll notice here we have Infura, Alchemy, and then over on the left, there's Etherscan. These ones are very low impact keys. They're meant to be exposed either on the client side or server side. Basically, they just talk to different Web3 components, and that makes up over half of the keys that I found. But the interesting part is when you look at the next top three, MongoDB, GitHub, and AWS. Those secrets, if they're exposed, are very bad. But secret scanning and looking for secrets is, secrets they're a bit like onions, right? They have layers. So the first layer is, okay, they're exposed, that's bad. The second layer is, if they're exposed and they have loose access controls or their permissions are poorly structured, that's when it gets really bad, right? So if I had a GitHub pat that has full admin access to my GitHub repositories and it exposed, that's bad, that's really bad. But if I had a GitHub pat that only had access to my public repositories, read access, it's an issue, but it's not that big of an issue, really. And where am I finding these secrets? So I spoke before, NPM and PyPy, Paul mentioned it. These are just basically package registries where Python and JavaScript code are hosted. And that's the main reason why 50% of the secrets are found in JavaScript packages, JavaScript file extensions, right? Because that's where I was looking the most, and that's where the most code is, so that's where the most secrets are going to be. No extensions are just files that had no extension. Python, pretty self-explanatory. And then the other ones here are where you would commonly hold credentials. So things like YAML files, JSON files, maybe in your Markdown, if you want to do that. But yeah, I just wanted to put this slide in here to showcase that a lot of these secrets are coming from NPM. Over 50%. I think out of the entire research, it was more like 80% of the secrets were from NPM and 20% were from PyPy. So the perfect storm. This is where usability meets visibility, and it creates a sort of ecosystem that makes it very easy as me as a developer to push code to these registries, right? And it also makes it very easy for me as a bug bounty hunter or a researcher to find these secrets. So when I talk about usability, it's like, as an engineer, how quickly can I push code to NPM and PyPy and get it in a public registry for other people to see? And what blockers exist for me to do this? With NPM PyPy, it's really easy. It's literally, I think with PyPy, it's a couple more commands, but on the CLI with NPM, once you're logged in and authenticated, it's literally just NPM publish, and then bang, it's on the registry, right? The reason I wanted to bring this up is because some organizations, and I'll talk about this a little bit later on, actually have native secret scanning baked into their applications. So when you're doing like a git push, for example, GitHub will natively scan that push commit for secrets if you have it turned on, but I'm just talking like as a brand new user to the platform, hasn't configured anything, it will natively be turned on and you'll get warnings if you have secrets inside your code. For NPM and PyPy, none of that exists. And the main reason for that is primarily, I think, because they don't want to be a blocker. They want to allow people to ship faster, and they don't want any blockers for their engineers or their users, right? Which is great from an engineering perspective, it allows them to ship faster, but it's not great for someone that's committing secrets accidentally. So I'll talk a little bit about deployment workflows and things like that because it makes sense with one of the examples that I have later on. But basically, a traditional GitHub workflow to deploy a package is something like this. So you have a developer that creates a PR. Everyone here knows GitHub, right? I'm assuming has a fair understanding. Okay, cool. So you have a developer, right, that creates a PR. And when that PR is created, they might have some code in it. A PR workflow runs, and that does some secret scanning, some different linting, some tests. Let's say that they all pass. There's no secrets. Good job. All the linting pass, the test pass, and then it goes into a branch. And then one of the other engineers from your company looks at the branch, approves it, does a merge. After that merge happens, then the deployment workflows kick off. So maybe you're building and you're deploying to NPM, right? So when that happens, it'll automatically deploy the package to NPM, and then other people will be able to use it. Same for Docker and PyPy. And this is a typical deployment workflow that you would find in most cases. We can also have an even cooler traditional deployment where you introduce a pre-commit hook early on in the workflow. So a pre-commit hook just means that as you're doing a commit, a tool hooks into that commit and scans it before it actually goes into a PR. And this is pretty important because you want to avoid having secrets enter your Git stream at all, because Git is just a complete hell. Like, it's very difficult to keep things out of there once they're in there. So you want to have a pre-commit hook. But the issue is that it requires additional setup on the developer's machine, and it's not as automatic as like PR workflows and things like that. So I don't commonly see pre-commit hooks. Don't think many people often use them. The main idea is that it's like a PR workflow that you have run over just to make sure everything makes sense, all the checks pass, and then you would just do the merge. So this is an example here of a secret being blocked from entering a GitHub repo. This is just an example one that I have. So I had AWS secrets inside my Git repository, my Git commit. And then I just did a git push to that repository, and GitHub has blocked it. So you can see there it's detecting some AWS access keys. It's saying, hold up a second, you have these secrets in here. Let's figure out what's wrong with them. Are they test credentials, things like that. Let's try and get them out of there. This is also what it looks like from the GUI. So you just have an alert basically saying that there's secrets inside your commit, and then you have to acknowledge, where they're found. So is it used in tests, things like that. This is great by GitHub. They didn't always have this, by the way, but I think it's only been in recent years that they've started to actually look at secrets inside, their repositories, because it's a pretty big deal. GitHub is sort of the main area that people are looking at secrets, because that's where most of the source code's held, right? And they've acknowledged that this is an issue, and they're actively working to fix it, which is awesome. Other organizations also do this as well. So I don't know if you guys have heard of Hugging Face before, but it's essentially just GitHub for AI, ML repos and things like that. They didn't always have this either. It was only after they acknowledged that lots of secrets were being leaked inside Hugging Face repositories that they decided, hey, we need to take a look at this and figure out a way that we can stop our users from publishing secrets, because it's harming the users, right? So they actually partnered with Trufflehog, which is the tool that I used, to detect these secrets. It's not proactive, so it doesn't stop secrets from entering the repositories. But once you do publish them, you will get like a nice little email like this saying, hey, you've published your secrets, you need to check them out, right? But what does NPM do about this? Well, they actually do alert on some secrets. Paul knows about this. They alert on some secrets, but it's literally just NPM tokens. So if you're not familiar, an NPM token just allows me to programmatically talk to my NPM registry. And it's pretty bad if it's exposed, because as Paul was mentioning, if I have access to someone's registry, I can push whatever code I want to that registry, right? So as a bad actor, if I have access to a well-known package, a well-used package, I can push whatever code I want to it via an NPM token. It's not a good thing. It is a good thing that they're alerting on this and they're letting you know that you've exposed your token. They actually go a step further and they revoke the token as soon as it's been published. So I tested this the other day, and I had basically just a script running, hitting a who am I endpoint with my NPM token. I published the token, and pretty much instantly it was revoked. So there's no room for maybe there's a 5-minute downtime where I can find the token and use it. So this is great that they're doing this, but again, they're not alerting on everything. This is just what it looks like in an email form. So they do let you know that you've been leaking bad things and you shouldn't be doing it. But if you remember before, I talked a little bit about how traditional deployments work and how commonly publishing packages happen from GitHub repos, right? Within actions and things like that. It's not often that a developer is actually doing an npm publish from their CI or from their CLI. It's commonly happening inside a GitHub repo and it's all automatic. If that's the case, then do we really need the npm token to compromise their package? Or can we just use a GitHub pat? You can just use a GitHub pat. You don't actually need the npm token. And I have a good example of this. So last month, I found a pat that belonged to one of Malaysia's largest or close to largest SaaS providers for restaurant management software. And the pat was just exposed in one of the npm packages. And it was consistently being exposed. Every version, they were leaking it. And it was leaked in some really weird files. So I disclosed this to the organization. And I was like, hey, you're leaking your GitHub pat. It has access to your npm registry. It has access to your GitHub registry via the different workloads that you have. There are around 36 different packages affected. And this software was being pushed out to their customers and clients, right? So not great that it's been leaked. If someone else had gotten hold of it, they could potentially push malicious code to it. And after discussing with them a little bit, and I was trying to figure out exactly how this happened, because they mentioned they had secret scanning at some point in their workflow, but the secret was still being published into their npm package. So this is what their workflow looked like. I don't think they had the pre-commit hook, but I just left that in there. So basically, they would have a package, the package that they were publishing. It would go through this whole life cycle, but when it hit the build and deployment phase, secrets were being introduced at this point, right? And that meant that it was skipping out on the secret scanning phase in the workflow. So early on, it looked like, hey, this package is all good, green light, let's publish it. But when it hit the build phase, because of a misconfiguration with their GitHub action, it was actually injecting secrets from their action or their repo variables into the package itself. So they had no idea. They thought the package was being published clean, but it wasn't. There was a GitHub pat in there, obviously, and they had no idea about it. And that's why I think we need to start looking at the end product. So the registry never lies. Basically, you can be sure to find what you're looking for, or secrets, things like that, inside the npm package themselves. You shouldn't just be looking at the place that they're built in the GitHub repository, because as we just looked at, secrets might be introduced somewhere else. But also because the way npm is set up and how easy it is for developers to push packages, they can bypass this pretty easily. Unless your organization has really strict access controls or has npm set up perfectly, which is quite rare, you're probably going to miss a lot of the stuff that's been published to the npm registry. So we should always look at the npm registry itself and try and determine what's inside these packages. Are we leaking any secrets? Are we leaking any confidential data inside the package themselves? You can do this pretty successfully. This is how I do it inside my research right now. So basically, I monitor the npm registry and PyPy registries consistently. I poll the RSS feeds. So my basic workflow is I query their RSS feeds, which have lists of created and updated packages consistently flowing in. And then I'll resolve these packages to authors and maintainers, because I want to work out which organizations are publishing these things, right? And then I'll send it to an Amazon SQS. An SQS is just like a simple queue service. Basically, it just allows me to send lots of different messages to it. And then I have another automation that sits in a container that pulls from the SQS and then scans the packages for secrets, and then we log the results. And this works really well. It's a really good way to continuously monitor what's being published to the registries. And it has helped me find a lot of bugs and disclose to a lot of different organizations. And not many other people are doing this. I set up some canary tokens in one of my packages just to work out, who is going to be scanning it. And there was not that many hits. Not as many as I would have hoped for, actually. I think Paul was one of them, and a couple of other organizations that do it. But there's not too many other orgs that are actually scanning consistently these packages across NPM and PyPy. The total cost for this too is really cheap. So if you want to do it yourself, it's like $15 a month. I use a VPS in OVH Cloud, which is really, really cheap. And then the SQS, so the Amazon side of things, is like $1.50. You can also do this hosting on-prem if you want, and it will literally just be $1.50 US a month if you want to do it. And this is more than enough beefy CPU and stuff like that to consistently scan these packages and not miss any. Another way you can do it, which is how I primarily started this research, was by looking at the NPM registries as a whole. NPM and PyPy registries, sorry. So basically the tough thing about NPM and PyPy is that it's extremely difficult for you, or like as a researcher or as an engineer looking into it, to determine what organization owns what package. You can't just say, you can't do a search to go, hey, I want to find out all the packages that are owned by Google. It's not how it works. There's no API endpoints for that. So the way I got around this was pretty much just replicating the whole entire NPM and PyPy registries into my own databases. And then I have all this data that I can query and say, I want to find out all the packages that belong to Google, right? Because I want to target them and scan them. And this is also a great way, if you're an organization that's maybe not sure of what's inside these registries, to really map out your footprint and figure out what your developers are pushing and remediate any issues and things like that. So if you're an organization that you want to do this, or if you guys, like I know a lot of you guys are students, if you want to do some bug bounty research and you have a target that you want to look at, you can easily replicate this stuff, store it in a cheap DynamoDB or like a MongoDB or something like that, and just look at the targets that you get back, look at the packages, who owns them, and then just start scanning the targets. So I have this script here, Revelio scan, that will do this all for you. It's basically just a wrapper for Trufflehog inside a Docker container. They'll hit the different necessary endpoints to retrieve information about these packages, the source code, and scan them for yourself. And I'll also be releasing RSS scanners too in a couple of weeks. So at B-Sides Camp, after my talk at B-Sides, I'll release the RSS scanners there, and you guys can continuously monitor the stuff too. But if you're an organization and you want to sort of remediate any issues in NPM and PyPy, or figure out what you guys have, you should always look at replicating the database, figure out what packages belong there that you own, scan the targets, remediate it, and then continuously monitor. And after that, you'll be pretty much sure that there's no secrets entering the workflow after that. You might miss a couple with errors and things like that, but it's a good way to start and a great way to proactively investigate these packages, especially if you have GitHub repos, because as we mentioned, it's not always great just to look at the source. You should look at where it's been built. You should look at the source as well. But that's pretty much it. I've finished up now. If anyone has any questions, I think we have a fair bit of time spare. Yes, Donnie.
Yeah, first of all, great talk. My question is, when you're working for an organization, you've got like a lot of developers, right? That's a lot of potential people that can, maybe accidentally or maliciously push NPM. Do you have any solutions on the maybe endpoint side, sort of tap that before the secrets get pushed?
Yeah, that's a great question. So Donnie was asking, if you have an organization that has a lot of developers and engineers that are pushing packages, from an endpoint side, how can you detect what those developers are pushing before it hits the registries? Right, Donnie? Yeah. That is a great question. There's no real easy answer that I can think of. For me, it's looking at the registry itself is a really reactive way to do it, because once it's up, once a secret or a malicious package is up there, anyone can get access to it. But it is one way to remediate it. So I'm not sure, besides using something like JFrog Artifactory to have your own private registry and then essentially blocking any pushes to NPM and stuff like that. But yeah, it's a great question. I don't know the answer to that one, unfortunately.
Great, thank you.
Yeah.
How much were you paid for that Malaysia fine?
For the Malaysia fine, that was just a public disclosure, so didn't get paid for it at all. I just let them know. Normally I wouldn't do it because there's a lot of legal, it's like a gray area to say to an organization, hey, I found this secret. I will say, if you guys are going to do this and you're looking for secrets, make sure it's for bug bounty programs, BDPs, things that have security programs. If you do find secrets that belong to just an organization, make sure you're not using them or anything like that. So it's a little bit of a gray area. You shouldn't be using stuff that doesn't belong to you. But yeah, I felt the need to disclose to them because the risks were just too big to not let them know that they were, exposing a secret that could be used for very bad, like a very bad supply chain attack, essentially. Yeah. Cool.
I'm not scared. Trufflehog, correct me if I'm wrong, Trufflehog only uses regex, is that right, Lee?
Yeah, they just do regex checking. So yeah, Trufflehog, that's a good point. So Trufflehog will just, essentially what it does is checks for different strings that match secret, like different secrets, right? Different detectors. And then it will hit different API endpoints to verify those secrets. So it will miss some things depending on how the secrets are exposed. If they're different strings chopped up, spread out, I don't know why anyone would want to do that, but it will miss that. So it's not an all-encompassing solution, but it does find most things. There's also other different tools like Git leaks, right, that do this and stuff as well.
Yeah, my follow-up to that is just to say that this is one of the problems with GitLab's CSECcon program, is that it's regex only. It's volunteer, so they're only going to be checking regex for keys that the company has interacted, has signed up themselves voluntarily to be a part of the secret scanning program, right? So it's like, it's a relatively small, they say 800 or 900 or whatever, but it's a very, very small number.
Yeah. Yeah, for sure. Hello, Ben.
Just based off that question in Trufflehog using regex, do you know of any tools that are using LLMs to help identify secrets?
Not off the top of my head. I'm sure they're being built. I don't know if Paul knows any that are out there. The question was any organizations or tools that are using LLMs to detect secrets instead of regex.
I write custom prompts, that's all I do.
Yeah. It's definitely something I've played around with a little bit, but it's just, yeah, then I don't think LLMs are quite there yet to, detect and verify. Cool. Sweet. Well, no more questions. Thanks for listening, guys. Really appreciate it.